Okay, we're going to look at some basic differentiation. Differentiation is all about finding the gradient of a tangent of a function. So it can sometimes be presented to you as a question to find the gradient of the tangent or find the rate of change. There's some more language that's used, or find the derivative, and sometimes the question just says to differentiate. The basic rule being that you bring the power down, multiply and take 1 away from the power. So let's first of all differentiate y equals x to the 7. So bring the power down, multiply, take 1 away from the power, and that's 7x to the 6. If we're going to differentiate x to the 15, bring the power down, multiply, take 1 away from the power, that would be 15x to the 14. Okay, so if we were to differentiate x to the minus 7, bring the power down, multiply, take 1 away from the power, that will be minus 7x to the minus 8. I can now use my rule of indices, which is a to the minus n equals 1 over a to the power n, to now bring the power down and get minus 7 over x to the power 8. Okay, next one, x to the minus 100, differentiate. That will give me minus 100 x to the minus 101, which you can tidy up, minus 100 over x to the positive 101. Okay, let's try some with fractions. So x to the power 5 over 2, bring the power down, multiply, and take 1 away from the power. So that's going to be 5 over 2 take away 1, so 5 halves take away 2 halves, for example, of a pizza will give me 3 halves, and that's to the power 3 over 2. I can now write that in root form, so that will be 5 halves multiplied by the square root of x all cubed, and the rule I'm using there is a to the power m over n is equal to the nth root of a brought to the power m. Okay, x to the power 7 thirds, bring the power down, multiply, take 1 away from the power, so that'll be 7 thirds x to the, well, it's 7 thirds take away 1, so 7 thirds of a pizza take away 3 thirds of a pizza will give me 4 thirds. Introduce the root symbol, so that will be the cube root of x brought to the power 4, so again that's using a to the power m over n is equal to the nth root of a brought to the power m. Okay, let's try another. So let's go for x to the minus 5. That'll be minus 5x to the minus 6, which is minus 5 over x to the 6. X to the 1/3. So that'll be 1/3 x to the, well, it's 1/3 take away 1, which is 1/3 take away 3 thirds, which is minus 2 thirds. Can then bring the power down, so that will be 1 over 3 lots of x to the positive 2 over 3, which is 1 over 3 lots of the square root of x all cubed. Okay, let's try x to the power minus 2 over 3. Bring the power down, multiply, take 1 away from the power, so that's minus 2 thirds x to the minus 5 over 3, and that comes from minus 2 thirds take away 1, it's minus 2 thirds take away 3 thirds, which is minus 5 thirds. Okay, bring the power down and make it positive, so that's 3 lots of x to the power positive 5 over 3, which is going to be the cube root of x brought to the power 5. Okay, just a brief aside. Remember that when you differentiate x, you get 1. If you differentiate 5x, you get 5. If you differentiate root 2x, you get root 2. If you were to differentiate minus 3.1x, you get minus 3.1. If you were to differentiate pi x, you get pi. So if you differentiate a constant x, you just get the constant. Now, if you differentiate a constant on its own, for example 5, then it goes to 0. Alright, so any constant when you differentiate becomes 0. Okay, let's try this one. So we're going to differentiate the square root of x to the power 5. So when you write the root, remember that the number up there is 2. So using my rules of indices, which is this one, and can be written as that as well, we can see clearly that that will be x to the power 5 over 2. And now differentiate it, and that will be 5 halves x to the power 3 over 2. I can then reintroduce the root, so that will be the square root of x cubed, 5 halves of the square root of x all cubed. Okay, let's try differentiating the fourth root of x to the power 5. So again, using that rule, that can now be written as x to the power 5 over 4. Bring the power down, multiply, take 1 away from the power, that's 5 quarters x to the power 1 quarter. And I got that because 5 quarters take away 1 is 5 quarters take away 4 quarters, which is 1 quarter. That can now be written as 5 quarters of the fourth root of x. Okay, let's try another. So this time we're going to differentiate the seventh root of x. So remember that that is x to the power 1, even though I've not been told that in the question, I know that it is. That can now be written as x to the power 1 over 7. So that's 1/7 x to the power, well, 1/7 take away 1 is 1/7 take away 7/7, which is minus 6/7. You can now bring that down, and that's 1 over 7 x to the power positive 6 over 7. And then I can finally reintroduce the root, and that will be the 7th root of x to the power 6. Okay, let's try differentiating the 5th root of x to the power 9. So that can be written then as y equals x to the power 9 over 5. Bring the power down, multiply, take 1 away from the power, so that's going to be 9/5 x to the power 4/5, so that's 9/5 take away 1, which is 9/5 take away 5/5, which is 4/5. So it's 9/5 of the 5th root of x brought to the power 4. Okay, let's try some different ones. So we're going to differentiate y equals 1 over x to the power 7. So we need to prepare to differentiate this one, which is to use the reciprocal rule in indices to bring that up. So that's going to be x to the minus 7. Bring the power down, multiply, take 1 away from the power, minus 7x to the minus 8. I can then bring the power back down, change the sign, that's going to be minus 7 over x to the 8. Okay, we're going to differentiate 1 over x to the 14. So that's x to the minus 14. Minus 14x to the minus 15, bring that down, and that will be minus 14 over x to the positive 15. Okay, we're going to now introduce a fraction on the denominator. So we're going to differentiate 1 over x to the 2/3, so that's x to the minus 2/3 by bringing that up and changing the power. Bring the power down, multiply, take 1 away from the power, minus 2/3 x to the, well, it's minus 2/3 take away 1, minus 2/3 take away 3/3, which is then minus 5/3. can then bring the power back down, and that will be positive, so minus 2 over 3x to the positive 5/3. Finally, I can introduce the root symbol, so it'll be minus 2 over 3 lots of the cube root of x brought to the power 5. Okay, so let's try y equals 1 over x to the 1/3. So that will be x to the minus 1/3. Bring the power down, multiply, take 1 away from the power, minus 1/3 x to the, well, minus 1/3 take away 1, minus 1/3 take away 3/3, which is minus 4/3. We'll then bring that back down, make it positive, so that'll be minus 1 over 3x to the positive 4 over 3. I can now reintroduce the root symbol, or introduce the root symbol rather, so that will be minus 1 over 3 lots of the cube root of x brought to the power 4. Okay, let's make it a wee bit more awkward again. So we're going to differentiate 1 over root x. Well, first of all, remember from indices that the square root of x is x to the power 1/2. So that's 1 over x to the 1/2. I then bring that up, and that will be x to the minus 1/2. I can now differentiate, bring the power down, multiply, take 1 away from the power, minus 1/2 x to the, well, it's minus 1/2 take away 1, minus 1/2 take away 2/2, which is minus 3/2. Okay, so I can now bring that back down, make it positive, so that will be minus 1 over 2 lots of x to the positive 3 over 2. And finally, reintroduce the root symbol, minus 1 over 2 lots of the square root of x, all cubed. Okay, let's try this one. So y equals 1 over the 5th root of x. So remember that rule of indices tells me that the nth root of x is x to the 1 over n. Okay, so that's 1 over x to the 1/5. I can then bring that up, and that will be x to the minus 1/5. I can now differentiate, bring the power down, multiply, take 1 away from the power. So the power then is going to be minus 1/5 take away 1, minus 1/5 take away 5/5, which is minus 6/5. Okay, so I can now bring the power back down, and that will be minus 1 over 5x to the positive 6 over 5. Finally, reintroduce the root symbol, minus 1 over 5 lots of the 5th root of x brought to the power 6.